Thank you for joining me on exercise 3G. I'm going to be looking specifically at question 4, part D. This says find the complex number z that satisfies the following equations, and we've been given z plus 1 plus I over 1 minus 4i equals z minus 3i plus 2 over 2i plus 5. Well, I'm going to take these denominators and cross multiply and multiply them on the other side. So let's start with z plus 1 plus I and multiply that by 2i plus 5. And on the right we've got z minus 3i plus 2, and that's going to multiply with 1 minus 4i. Let's expand, and z times 2i is 2zi, z times 5 is 5z, expand with the 1 times 2i is 2i, and the 1 times the 5 is the 5, and now I times 2i is 2i squared, and I times 5 is 5i. Alright, that's the left-hand side. I didn't leave much room for the right-hand side, but let's now expand the right-hand side. Z times 1 is z. Z times minus 4i is minus 4zi. Now the negative 3i times 1 is negative 3i. Negative 3i times negative 4i is positive 12i squared. Finally, 2 times 1 is 2, and 2 times negative 4i is negative 8i. Okay, so what we've got here is a term which says 2i squared and a term which is 12i squared. Well, I squared is negative 1. So if we take 2i squared, that's 2 times negative 1. So I'm going to change that with a negative 2. And the 12i squared is actually 12 times negative 1, which is negative 12. So I'll change those. Let's change those now. So we've got 2zi, 5z, 2i plus 5. We'll change this to a minus 2 plus 5i equals z minus 4zi minus 3i. We'll change this next term to minus 12. We've still got the plus 2 and the minus 8i. Now I'm going to take all the z terms and I'm going to put these z terms on the left hand side. So we've got 2zi, 5z, take that positive z across to be a minus z, take the minus 4zi across to be plus 4zi, and we'll take these terms without the z, put those on the other side, and these are already over there. So let's rewrite negative 3i minus 12 plus 2 minus 8i, and bring over the plus 2i. So this comes across to be a minus 2i. This comes across to be a minus 5. This term goes across to be a plus 2. And this term goes across to be minus 5i. Right, so let's scroll up and factorise the z out of each term here. So we've got 2i plus 5 minus 1 plus 4i. And on the right hand side, let's take the real components and add them together. So that becomes negative 12 and 2 is negative 10. Take 5 is negative 15 plus 2, negative 13. Okay, so negative 13 is the real part. The imaginary part is negative 3i, negative 8i, negative 2i, negative 5i. That makes negative 18i. Alright, simplifying this bracket here, we've got 5 take 1 is 4, 2 plus 4 is 6i is the imaginary component, and we've got negative 13 minus 18i. We'll leave the z here. We'll take that numerator and we'll divide it by that factor 4 plus 6i. And now, to finish, we need to multiply by the conjugate of 4 plus 6i. That's a plus, the conjugate has a minus. So it's 4 minus 6i. And let's expand. Negative 13 times 4 is negative 52. Negative 13 times negative 6i is positive 78i. Negative 18 times 4 is negative 72i. Negative 8i times negative 6i is positive. 6 8 48, 108. Because 6 times 18 is 108. I times I is I squared. And the denominator, we've got a plus b, a minus b, which is a squared minus b squared. So that makes 4 squared is 16 minus 6i times 6i is 36i squared. Real components, 108i squared. 108i squared is 108 times negative 1. We'll replace that with negative 108. So let's just do that. And we'll divide that by 16 and minus 36i squared. Well, 36i squared, or we'll take away 36i squared is negative 36 times negative 1. We'll replace that with plus 36. All right, real components are negative 52 and negative 108, negative 160. Imaginary components, 78 minus 72 is 6i, and 36 plus 16 is 52. If we split this up into negative 160 over 52 plus 6 over 52i. Cancelling 4 out of the first fraction, we've got negative 40 over 13. Cancelling 3, 2. 2 3s, 6, 2 26s. So we've got 3 over 26i. Well, I hope this has helped. Until next time, stay happy.